Hi everybody, welcome to Purdue Space Program Liquid's CraterMaker Special Full Duration Hot Fire. Today, we are at Zucrow Labs in West Lafayette, Indiana, and we will be testing CraterMaker Special systems to prepare for launch in Mojave, California later this year. I'm Benton, a sophomore in aerospace engineering and the business lead of the team.
And I'm Ian. I'm a senior in aerospace engineering, and I'm the technical director for PSP Liquids.
The test we are conducting tonight is a full duration hot fire, which is a flight-like simulation of our propulsion system. We're going to fill CraterMaker Special with its propellants and ignite them in the rocket's engine's combustion chamber to create a little under half a ton of thrust. The rocket will be held down by a support structure, and we will be able to measure the thrust of the engine. The goal of this test, as with all of our vehicle tests, is to collect as much data as possible. So we have over 20 sensors transmitting data to our test conductors.
This hot fire is one of the last milestones on our pathway to launch CraterMaker Special in the Mojave Desert in California in a few weeks. We're very excited to have you with us and a part of the action. We've begun propellant loading, which means that we are filling CraterMaker Special with liquid methane and liquid oxygen, which are the fuel and oxidizers that we use to propel CraterMaker Special into the skies. The fuel and oxidizers are both cryogenics, which means they are extremely cold. In a few minutes, you'll start to see both our tanks and tubing frost up with some ice and snow, and that's why. We have liquid oxygen, which is at around negative 300 degrees Fahrenheit, so very extremely cold stuff. And with that, we have to take additional safety measures. Above just loading in liquid oxygen and liquid methane, we're also going to be filling CraterMaker Special with helium, which is what we use to pressurize our fuel and oxidizer tanks, which feeds the fuel and oxidizer through the system and into the combustion chamber. We've already completed some leak checks and other checkouts for the vehicle, so we're rolling straight into propellant loading, and then shortly after that, we'll do the hot fire test.
As the Liquids team, we strive to create an exciting and welcoming environment for all students to cultivate their engineering skills outside the classroom. I'm very proud to be a part of this team that provides invaluable technical experience to all of its passionate members building tomorrow's workforce. PSP Liquids is Purdue University's liquid bipropellant rocketry team, providing students the experience sought out by the aerospace industry. The team fosters professional growth through practical work in the analysis, design, and manufacturing and testing of liquid rockets, as we prepare members for the next giant leap in their careers. A brief history about PSP Liquids. Purdue Space Program Liquids was founded in 2017 and started development on our first rocket, Boomy-Zoomy. While Boomy-Zoomy never made flight, its successor, Boomy-Zoomy-B, abbreviated BZB, was developed and flown 3 times, twice in the same day, at Friends of Amateur Rocketry, or FARS, site in Mojave, California. Liquids has now set their sights on CraterMaker Special, which is the rocket that we are currently testing today. CraterMaker Special is fueled by a liquid methane and liquid oxygen engine. It uses an ablative engine, which basically it ablates away heat to keep it cool during flight. I think we have a specimen actually right here. So this is from BZB's testing campaign. As you can see, the inside of the chamber has kind of turned white and like calcified. Basically, in order to keep the engine cool, part of the engine burns away with the actual fire that it makes. And with an ablative engine that we manufacture in-house.
So we made this, we didn't make this one in-house, but the one on the vehicle right now was all made in-house by students on our team. We're actually going to be able to show you a video soon about the manufacturing process for that.
Hi, my name is Andrew Neri. I'm a junior in aerospace engineering, and I'm the PSP Liquids Propulsion Lead. So currently, we're working on winding our combustion chamber for CraterMaker Special in carbon fiber. This is an ablative combustion chamber, meaning the inside liner is made out of a very high temperature material designed to slowly erode and carry away combustion heat as the engine burns. That liner, though, however, is very brittle, so to provide structural strength to withstand chamber pressures from combustion, we wrap the outside in carbon fiber. This is done with the filament winder that we designed and built in-house, including all the software. So we manufacture the entire engine, including the ablative and the filament wind in-house.
That video is just a short glance on some of the things we do on PSP Liquids. But in the future, we're setting our sights higher for our propulsion system. So for Copperhead, our newest vehicle that we're developing on PSP Liquids, we're going to be using a regeneratively cooled engine. You'll hear more about that later from our propulsion lead, Arjit. But for now, let's get some more scenes of the courtyard.
Ian, can you explain to me what the purpose of our test is tonight and a little bit of its details?
Absolutely. So the main purpose of this test is to vet out our propulsion system and the entire rocket system as we prepare for getting into launching CraterMaker Special in just a few weeks here. So the main goal is to go through the entire process of filling the rocket with our propellants and then go through the process of pressurizing the vehicle with helium and then letting it rip, letting the engine run, and going for a total of 13 seconds, which is our full duration burn time for the engine. And then afterwards, we'll take all the data we learned from the test and go over it, make sure everything is up to snuff, and then we'll roll into launch prep shortly after that. So this is, like I said earlier, this is the last major milestone for CraterMaker Special before going into launch.
One of the things that we mentioned early on is that there are over 20 systems in the vehicle. Can you explain a little bit more about those sensors and how we collect our data?
Yeah, so a lot of data is going from the rocket and from our ground support equipment to our operators in control rooms. We have data on pressure, we have data on temperature, and a whole lot more. Let's cut back to some more views from the courtyard.
So we just heard from our test operators that there has been a bit of a delay. Ian, can you explain some of our delay to us?
Yeah, so right now we're facing a 60-minute to 90-minute hold as we reconfigure some of our propellant fill system. Everything is nominal so far. We just want to make some adjustments to make sure we have a flight-like simulation of the load sequence for the liquid methane. So everything is nominal. We just need to take a step back and address some things. For now, you're going to be stuck with us, though. We have a full schedule planned for you all. So thank you for continuing watching. We'll cut back to the courtyard now so you can see some more shots of our rocket.
Thank you so much for your patience.
So while we wait on the hold, we're going to be going over the system in depth to explain what we're doing and why we're doing it.
Yeah, I have a few very important questions for you.
Yeah,
Can you
sure.
tell me about our launch system, Black Cat launch system?
Yeah, so Black Cat launch system is what we call our ground support equipment, which is BCLS for short. And that is a very important piece of our vehicle launch architecture. It's responsible for both filling the rocket with propellants, which is what you'll be seeing us doing very shortly. And it's also responsible for running any safing purges, which means letting nitrogen into the rocket to eliminate any potentially dangerous gases trapped inside of the rocket. It's also responsible for filling the rocket with helium, which is our pressurant, and it gives us a pipeline from the rocket to our control operators in terms of data. So it handles all the data processing for us and gets it to the people controlling the rocket during this period. So before we launch, everything from the rocket is going to be hooked up through BCLS. And then once we get into launching the rocket, we'll have a series of quick disconnects separate and end the connection between the rocket and the ground support equipment. And then the rocket will take off, and the BCLS system will safe itself, which means eliminating all pressure within its system.
And the crowd will go wild.
Oh yeah, big show.
Speaking a little bit more to kind of the following schedule for the rest of this live stream.
Yeah.
Once propellant filling is finished, what are some of the other things that we're going to encounter before engines light and fire gets made?
Yeah, let's run through like a very basic high-level view of the procedures we're doing. So first off, before we started the stream, we did a lot of work to get to where we are now. And it started off really with setting up our test area. So making sure we had all the cameras set up for this lovely live stream, making sure that all the equipment on the rocket and on the Black Hat launch system was properly set up. And then we ran into some pre-test checkouts for the vehicle, which includes leak checks. We want to make sure that both the rocket and the ground support equipment is not going to be able to leak. So we make sure that everything is tight and holding pressure. And then after that, we run into some checkouts for the vehicle system, which means making sure the valves that operate the rocket and the ground support equipment are functional, what we call click checks, turning on and off a valve, pretty much. A lot of that kind of stuff to make sure that we're ready to get into propellant loading, which is what we're waiting on right now. So a lot of work goes into it just to get to this point, and then from now to the hot fire test, we're going to be loading propellant, loading our liquid methane, liquid oxygen into their tanks, and then also loading in gaseous helium into the COPV, which is at the very top of the rocket.
Can I ask what a COPV is?
Sure. COPV is the white tank that you'll see at the very top of the rocket. It is called, well, it stands for Composite Overwrap Pressure Vessel, so COPV. It's able to contain gas at extremely high pressure, around 5,000 psi for us, which is, about 50 times more, or more than 50, probably almost over 100 times more than a car tire. So a lot of pressure is stored in that thing, a lot of energy. And we use that to pressurize our propellant tanks, which ultimately feed the engine with the liquid methane and liquid oxygen.
Interesting. My joke to that is that I think it's more like 200 times. My tire pressure might be a little low at only 30 psi.
You're telling me. I've been having my tire pressure alarm go off for the past week
cold
now.
weather,
Oh, yeah. You're getting into fall here.
So once the gaseous helium and the liquid propellants are in the vehicle, can you kind of run me through the flow of fluids through the system and how everything
Sure.
kind of coalesces?
Yeah, conveniently, it kind of goes from top to bottom on the rocket. The highest amount of pressure, which is stored in the COPV, is at the very top, and then it flows down as pressure does to lower and lower pressure stations, let's call it. So we start at the COPV, which stores our helium, and then that flows into our propellant tanks. So the aluminum bodies that are right now covered with insulation that black insulation is what's covering our propellant tanks. That stores the liquid oxygen and liquid methane. And as we said earlier, those are both extremely cold. They're at about negative 300 degrees Fahrenheit for the oxygen. And then after that, we flow from the propellant tanks through a bunch of plumbing and valve work into the injector of the rocket. And a lot of interesting stuff is going on with the injector. That's the part that's responsible with taking our two propellants and mixing them together to create a very fine mist. And then that mist is subsequently ignited in our combustion chamber by a pyrotechnic igniter. And then that's what starts the hot fire. And then we pretty much burn through all the propellant loaded on the vehicle. And that should last us about 13 seconds, which is the burn time of CraterMaker Special. And then afterwards, we safe the system, which means we, get all the pressure out of the vehicle, so we are able to safely approach it. And that's the plan for tonight. That's the hot fire procedures in a nutshell.
Interesting. You just mentioned that there were lots of valves and solenoids that the fluids needed to travel to. One of the very notable pieces of hardware right after the COPV and before it goes into the propellant tanks is our bang bang pressurization valve. Would you be able to speak a little more onto that?
Yeah, so in order to get the helium in our COPV into our pressure or into our propellant tanks, we have a system called bang bang. And what that means is we have two very quick acting valves to allow helium flow into the tanks at very precise timing. So if the pressure in the LOX tank is a little too low for what we want, we quickly open up that bang bang valve, and that allows more helium to flow in, increases the pressure in the tank. And then if we reach that pressure mark that we're trying to control to, we close that valve and stop the flow. So we're banging open and banging closed that solenoid valve, that quick acting valve, to control the pressure in our tanks.
Okay.
And that's a very common method in both college rockets and in industry level rocketry.
Interesting. So kind of going back to our tire analogy, is that the same thing or similar to kind of having a hole in your tire, but your air compressor is already hooked up to it and running it, so you're filling as much as you're leaking? Is that an accurate way to describe it?
Yeah, so as we're running our hot fire test, we're losing propellant through the rocket engine. The flames through this are effectively burning propellant. So as that mass exits the rocket, we have to make up for the pressure we're losing as well. So to do that, we have our valves running and supplying a constant pressure in our tanks to maintain a good steady state condition for our propellant tanks.
Interesting. Thank you so much for describing that.
Yeah, of course.
On a bit more of a personal level, I'm curious, what was your favorite part about, dealing with the CraterMaker Special rocket? What was your favorite part working about it?
Well, I started working on CraterMaker Special in my freshman year, which was really a dream of mine. I wanted to be a part of PSP Liquids ever since I was a high school senior. So being here and being a part of this hot fire and launch campaign is really, really something special to me. But my favorite part was probably working with all the members and engineers and everybody working on PSP Liquids. It's an amazing group of people, and I'm grateful every day to call them both my friends and my colleagues. It's truly an honor. So that's probably my favorite part. But my favorite memory, I'd say, is we spend a lot of late nights, as you can see on PSP Liquids, doing these kinds of unique tests. So being a part of those, always going to be something I look back on in the future and remember about my college experience.
Very nice.
Yeah. How about yourself? What was your favorite memory on PSP Liquids?
Very similarly to you, I kind of came to Purdue with the express purpose of joining Purdue Space Program. It was one of my deciding factors in picking my college. And I came to Purdue being a fairly well-performing student, at least in my mind. And Purdue is tough. It's a very amazing institution, but the classes are hard. And later in my freshman year, I had an amazing opportunity where a bunch of upperclassmen kind of pulled me aside and just straight up tutored me on some of my homework and some of my tests to really help me along. And it was an amazing moment because they'd been there too and they understood what the work it took. And it was great for a social aspect, and it also really helped my grades. And so that was definitely one of my favorite memories, and I know I'll make a lot more as I continue to be in the club.
Oh yeah, lots more memories to be had, and that, what you're saying is very, core tenet really of the team and PSP Liquids as a whole is the amount of community that we've grown here is really incredible. Everybody has each other's back, and the collaboration on this team is something really special, and we're all grateful to be a part of it.
Speaking on collaboration, I'm curious, what is the most interesting aspect of working with so many different subsystems? We have the fluid subsystem, we have the prop subsystem, we have the avionics subsystem, we have the manufacturing side of the equation. There's so many different subgroups and sub-elements to these massive vehicles, and what's that like managing all of it?
Yeah, with all those subs, you'd think we're running a submarine here. Yeah, there's a lot going on PSP Liquids, and that's kind of what makes it exciting. There's always something more to do. Right now, the team is growing at almost an exponential rate with the amount of cool stuff we're doing, which is amazing to see. So starting off, it's a lot of communication to, make sure that all the sub teams are talking to each other and, on the same page when it comes to building a really complicated thing like a rocket. There's a lot of stuff going on in the background. So making sure that all of our engineers are, collaborating and working together and putting together cohesive end product is, that's something that you only really get on a team like this. So my favorite part of that is probably just working with, the members on this team every day and hearing their ideas and being able to connect them with each other and make sure that, one member is aware of another member's decisions and making sure that all the links are coming together to form a nice tight team.
Absolutely.
Yeah. And then what kind of stuff do you do on the team, Ben?
Yeah.
You're a core member of the group here.
So as the lead of the business sub-team, my job is to ensure that Purdue Space Program Liquids always has the funds it needs and the industrial relations it needs to complete all of its objectives. We have over 30 sponsors, all of whom I interface with in varying ways, which gives a lot of opportunity to learn from industry and a lot of resources from the industry. Whether we get amazing opportunities for cash grants or amazing opportunities to get parts sponsored for us. An example of that is our injector plate for CraterMaker Special is actually sponsored by 3D Systems because it's entirely 3D printed. Those give us lots of opportunities to learn from industry, communicate with industry, and also do the things that we do. Elon Musk famously said, if you want to be a billionaire in rocketry, you should be a billionaire in another company first and then start a rocket company. This work isn't known for being inexpensive, and it's always amazing to see how many, professionals are always willing to help us in our endeavors, which is a lot of fun.
Yeah, we have a lot of supporters, and we're always thankful for what they've done for us. You'll be hearing some of our sponsors across the live stream.
And I'm curious, what do you do as technical director of the team?
Sure. So I'm, like Ben said, I'm the technical director on the team, and my goal is to really help PSP Liquids as much as I can in different ways. So trying to help with engineering decisions, trying to help with making the team more efficient as it works through complex problems like getting CraterMaker Special to launch, and then also the next rocket we are working on, which is called Copperhead. Just trying to help out our members, make sure things are running smoothly. I also handle some of the infrastructure of our team, so making sure that all this stuff supporting our wonderful engineers is maintained.
Thank you so much for that. We'll cut back to some camera views right about now.
Welcome back. We are going to be showing some views from across our test area. And while we're doing that, you might hear some intermittent mic callouts for our test operators. So if you ever hear that, those are our test operators running the procedure to operate the vehicle.
We try to put you right in the seat of the action, so you'll be hearing most of the callouts that all the operators make. Listen and learn.
Yeah. Okay, we'll let that simmer for Unfortunately, we're going to be scrubbing for tonight. Our operators are actively safing the vehicle and ground support equipment as we speak. That means that although we aren't going to be completing the test tonight, we're going to be reattempting as soon as we possibly can. We have a few issues to look into, but besides that, we're still very happy to have you with us today.
With that, we'll be closing out the stream here. We'll be getting back to hot fire testing as soon as possible, and we'll keep our socials updated with when our next attempt will be. Thank you so much for your time with us. Have a great rest of your night.